Hi, welcome back to my class in Calculus 2 or Integral Calculus. For today, we will complete our lesson on integration by partial fraction by taking the last case of integration by partial fraction, case 4. In case 4, the factors of the denominator of the rational expression in the integrand of the given integral contain quadratic factors that are repeated. So we take an example. In the given integral, the integrand contains this rational expression 2x over quantity x minus 1 times quantity x plus 4 to the power 2. You can see that x squared plus 4 is a quadratic expression, and it is one of the factors in the denominator of this rational expression in the given integrand. And this quadratic factor, x squared plus 4, is repeated 2 as indicated by the exponent, repeated twice as indicated by the exponent of quadratic expression x squared plus 4. And to start with, we write this rational expression as a sum of partial fractions. For the first linear factor, x minus 1, we use a constant denoted by a. The quadratic factor x squared plus 4 is repeated twice. For the first quadratic factor x squared plus 4, our numerator will have two constants of the form bx plus c. And the last term contains this quadratic expression to the power 2. You can see that the exponent of x squared plus 4 is increasing from here, it's 1, and then 2. If the exponent of the quadratic factor x squared plus 4 is 3, then you will still have to add another term with denominator x squared plus 4 to the power 3. And for this term, the numerator will be an expression of this form with two constants, and we write dx plus e. And we remove the denominators by multiplying both sides of this expression by the LCD x minus 1 times x squared plus 4 to the power 2. Multiplying the left hand side by the LCD, x minus 1 over x minus 1 will cancel out because it's equal to 1. X squared plus 4 to the power 2 will cancel out with x squared plus 4 to the power 2 in the denominator because it's equal to 1. And we are left with 2x at the left hand side. The first term at the right hand side, we multiply by x minus 1 and x squared plus 4 to the power 2. X minus 1 over x minus 1 is 1, and we are left with a multiplied by x squared plus 4 to the power 2. The second term at the right hand side, we multiply by x minus 1 and x squared plus 4 to the power 2. And x squared plus 4 to the power 2 divided by x squared plus 4 is x squared plus 4 multiplied by quantity x minus 1 multiplied by bx plus c. And the last term at the right hand side, we multiply by this LCD, x squared plus 4 raised to 2 over x squared plus 4 raised to 2 is 1. And we are left with bx plus e multiplied by x minus 1. And we remove the grouping symbols at the right hand side and we collect like terms. To the square of x squared plus 4, we apply the special product rule for the square of a sum. And we have a multiplied by the square of x squared is x to the 4. Multiplied by a is ax to the 4. The second term in the expansion of x squared plus 4 squared is twice the product of these two. 2 multiplied by 4 multiplied by x squared multiplied by a. And we get 8ax squared. And the last term in the expansion of x squared plus 4 squared is the square of the second term or constant term 4. Square of 4 is 16 multiplied by a is 16a. Plus quantity bx plus c. We first multiply x minus 1 and x squared plus 4. We distribute x, distributive property of multiplication from the left. Distributive property of multiplication, x times x squared is x cubed. Plus x multiplied by 4 is 4x. Distribute minus 1 minus x squared minus 4. And the last term, we multiply dx plus c by x minus 1. Distribute dx. Dx multiplied by x is dx squared. Dx multiplied by minus 1 is minus dx. E multiplied by x is ex. E multiplied by minus 1 is minus e. We still have to remove the grouping symbols in the second term by multiplication. Multiply bx by x cubed. You get bx to the 4. Bx multiplied by 4x, you get 4bx squared. Bx multiplied by minus x squared is minus bx cubed. And bx multiplied by minus 4 is minus 4bx. Also distribute c by multiplication. C multiplied by x cubed is cx cubed. C by 4x is 4cx. C by minus x squared is minus cx squared. And c multiplied by minus 4 is minus 4c. The last four terms are the same as is. We write dx squared minus dx plus ex minus e. Now we write the equation. We start with the constant terms at the right hand side. The constant terms are 6a, 16a, minus 4c, and minus e. And we equate this constant with constant at the left hand side, but the left hand side has no constant. So we equate this constant to 0. Call this equation 1. We call it equation 1. Now we consider the coefficients of x. We have minus 4b plus 4c plus minus d and plus e. Coefficient of x minus 4b plus 4c minus d plus e is equal to the coefficient of x at the left hand side, which is 2. And we call this equation 2. Now we consider the coefficients of x squared. We have 8a plus 4b minus c. And plus d, and we equate this to the coefficient of x squared at the left hand side, but the left hand side has no x squared. If it has x squared, its coefficient must be 0, or you can add anytime plus 0 x squared at the left hand side, and the left hand side is still 2x. So we equate this coefficient of x squared at the right hand side with 0. And we call this equation 3. Now we consider the coefficients of x cubed. We have minus b plus c. Minus b plus c is equal to coefficient of x cubed at the left hand side, but the left hand side has no x cubed. Thus we equate this constant to 0. Now we consider the coefficients of x to the 4th power, a plus b. And we equate this to 0. Now we have to solve for the constants a, b, c, d, e. But we can get one of the constants from this equation, from this expression, by letting x equals 1. If x equals 1, this would be 0, this would be 0, and this would be 1 squared is 1 plus 4 is 5. 5 squared is 25. And when x is 1, this is 2. So 2 is equal to 25a. Or a is equal to 2 over 25. Divide both sides of this equation by 25. Again, we get a equals 2 over 25 by letting x equals 1. Sum of these terms would be 0 if x equals 1. When x is 1, this term will go, and this term will go. And when x is 1, this term is 1 squared is 1 plus 4 is 5 squared is 25a. And when x is 1, the left hand side is 2 multiplied by 1 is 2. And we divide both sides of this equation by 25 and we get a equals 2 over 25. Now we have a, we can solve for b from this equation. Transpose a to the right hand side, b equals minus a. But a is 2 over 25, so b is minus 2 over 25. Since we already have b, we can now solve for c from this equation. Transpose minus b to the right hand side, you get c equals b. But b is negative 2 over 25, so c is negative 2 over 25. Now we have a, b, and c. We can solve for d from equation 3. d equals transpose minus c to the right, c. Transpose 4b to the right, you get minus 4b. And transpose 8a to the right, you get minus 8. Minus 8a. We substitute the values of a, b, c. d equals c 2 over 25. Minus 4 times b is negative 2 over 25. I'm sorry, the value of c is minus b, transpose to the right is b. c is equal to b, but b is negative 2 over 25. Therefore, c is negative 2 over 25. And this is c is negative 2 over 25 minus 4 times b, negative 2 over 25. Minus 8 multiplied by a, but a is 2 over 25. And you can see that common denominator is 25. We add the numerators. We have minus 2, minus 4 times minus 2 is positive 8. We have minus 2 plus 8 is 6. And minus 8 times 2 is negative 16. So 6 minus 16 is negative 10. And 10 over negative 10 over 25 to the lowest terms is negative 2 over 5. obtained by dividing 10, negative 10, and 25 by 5. The greatest common divisor of minus 10 and 25 is 5. Minus 10 divided by 5 is minus 2. 25 divided by 5 is 5. And lastly, we solve for the constant e from equation 1. You can also solve for e from equation 2, but it's easier to solve for e from equation 1. Transpose minus e to the right hand side. E equals 16a minus 4c. And we substitute the value of a and c. 16 multiplied by a is 2 over 25. Minus 4 multiplied by c is negative 2 over 25. And we see that there is a common denominator of 25. And we add the numerators. We have 16 multiplied by 2 is 32. Minus 4 multiplied by negative 2 is positive 8. And 8 plus 32 is 40. And 40 over 25 to the lowest terms is 8 over 5, which we obtained by dividing 40 and 25 by the greatest common divisor of 40 and 25, which is 5. 40 divided by 5 is 8. 25 divided by 5 is 8. Now we will substitute the constants, the values of a, b, c, d, e in here. And we change this to equality. This rational expression is now equal to the sum of partial fractions with the values of a, b, c, d, e substituted. And we will integrate both sides with respect to x. Now substitute the values of a, b, c, d, e in this expression. Now this rational expression, which is the integrand of the given integral, is now equal to a 2 over 25 over x minus 1 plus b negative 2 over 25 multiplied by x plus c. C is minus 2 over 25. Over x squared plus 4. And the last term is b, negative 2 over 5, multiplied by x. Plus e, 8 over 5. Over x squared plus 4. X squared plus 4 to the power 2. And we now integrate both sides with respect to x. There, it's already indicated with respect to x. can see that the left hand side is already the given integral, which we are now solving. We apply the property of one of the integration rules. The integral of a sum is equal to the sum of the integrals. So the first term is equal to the integral of 2 over 25 over x minus 1 with respect to x. And to the first term, we apply another integration rule. The integral of a constant and a function is equal to the constant times the integral of the function. So the first term is equal to 2 over 25 times the integral of dx over x minus 1. And this is readily integrable. It's equal to ln of x minus 1. You can see in the numerator of the second term that minus 2 over 25 is a common factor. So we factor out minus 2 over 25 and multiply that by positive. And it becomes minus 2 over 25 times the integral of x plus 1 over x squared plus 4. And in the last term, we have positive times negative is negative 2 over 5 times the integral of x over x squared plus 4 to the power 2. And the last term is 8 over 5 times the integral of dx over x squared plus 4 to the power 2. This one is readily integrable. It's ln of x minus 1. And this one, integral of x plus 1 dx over x squared plus 4, we have to write this as the sum of two integrals. The integral of x with respect to x over x squared plus 4 plus the integral of dx over x squared plus 4. To integrate this term, integral of x dx over x squared plus 4, and to evaluate this integral of x dx over x squared plus 4 squared, we make use of a substitution by letting u be equal to x squared plus 4. If u equals x squared plus 4, we differentiate both sides. U with respect to u, differentiate u with respect to u, you get 1 times derivative of u is du. And differentiate the right hand side with respect to x. Derivative of x squared is 2x. Derivative of 4 is 0 multiplied by dx. And in this integral, we have x dx in the numerator, as well as in this integral, we have x dx in the numerator. So we solve for x dx from this equation by dividing both sides by 2. So x dx equals du over 2. And we will use u equals x squared plus 4 and x dx equals du over 2 for this integral and for this integral. Now, to integrate this integral of dx over x squared plus 4 and the integral of dx over x squared plus 4 squared, we make use of trigonometric substitution. For the sum x squared plus a squared, we use x equals a tangent theta, where a is 2, 4 can be written as 2 squared, so we let a equals 2. Again, x squared plus 4 can be written as x squared plus 2 squared, where a is equal to 2. If you have an expression of the form x squared plus a squared, the trigonometric substitution to use is x equals a tangent theta. If you have x squared plus square of a, where a is a constant, and in this particular example, a is equal to 2. Now we get dx by differentiating both sides. Derivative of x is 1 multiplied by dx. At the right hand side, we have 2 times derivative of tangent is secant squared theta. Multiplied by d theta. For this integral and this integral, we replace dx with 2 secant squared theta, d theta. And we replace x with 2 times tangent theta. The first term is as is 2 over 25 times ln of x minus 1. We have minus 2 over 25 multiplied by the integral of x dx is du over 2 x squared plus 4 is u plus the integral of dx 2 secant squared theta d theta divided by square of x. X is 2 tangent theta and square it plus 4. This term is minus 2 over 5 times the integral of x dx is du over 2. X squared plus 4 is u squared. And the last term is 8 over 5 times the integral of dx. dx is 2 secant squared theta d theta. Over square of x. X is 2 tangent theta squared plus 4 to the power 2. There we have done the substitution, and we will now simplify this term and this term using trigonometric identities, in particular one of the Pythagorean identities, but this term is readily integrable. You have 1/2 is a constant multiplied by negative 2 over 25. 2 over 2 will cancel out, and integral of d over u is ln u. This one is also readily integrable. Again, 1/2 is a constant multiplied by negative 2 over 5. 2 over 2 will cancel out. You get negative 1 over 5 times the integral of du over u squared, where we apply the power rule. We take u squared to the numerator, and you get the integral of u to the minus 2 with respect to u. And that's where we apply the power rule. And the last term we have to simplify by using a trigonometric identity. The given integral of 2x dx over x minus 1 times quantity x squared plus 4 is now equal to 2 over 25 multiplied by ln of x minus 1 minus 2 over 25 multiplied by 1/2. 2 over 2 will cancel out. 2 over 2 will cancel out, and you get negative 1 over 25 times the integral of du over u. And the integral of du over u is ln of u. Where we left u earlier as x squared plus 4 for this term. Now we simplify this term by using a trigonometric identity. We have the integral of 2 is a constant. We can apply one of the integration rules. So we write this as 2 times the integral of secant squared theta d theta. And the square of 2 tangent theta is 4. Square of 2 times the square of tangent is 4 tangent squared theta. And the last term is 4. And this one simplifies to negative 1 over 5. 2 over 2 is 1. You get negative 1 over 5 times the integral of du over u squared. We write u squared to the numerator. We get minus 1 over 5 times the integral of u to the negative 2 du. And we apply the power rule. The last term is, again, 2 is a constant. We multiply 2 by 8 over 5. We get 16 over 5 times the integral of secant squared theta d theta. And in the denominator, we take the square of 2 tangent theta equals to square of 2 times square of tangent theta is 4 tangent squared theta plus 4, and the sum is raised to the power 2. We now replace u with the substitution we used earlier, where we let u equals x squared plus 4. And in the denominator here, we factor out 4. And that's 1 over 4 multiplied by 2. That's 2 over 4. And in lowest terms, it's 1 half. And Pythagorean identity says that square of tangent theta plus 1 is equal to secant squared theta. And by power rule, integral of u to the minus 2 with respect to u plus 1 to minus 2, you get u to the minus 1 and divide by minus 1. And minus 1 over 5 divided by minus 1 is positive 1 over 5. Positive 1 over 5 and multiply by u to the minus 1. In the last term, we factor out 4. You see 4 is raised to the power 2. This is 4. This is equal to the square of 4 times tangent squared theta plus 1. So 4 is raised to the power 2, that's 16, and you have 16 in the numerator. 16 over 16 is 1. So the coefficient of the last term is simply 1 over 5. And again, by Pythagorean identity, the square of tangent theta plus 1 equals secant squared theta raised to the power 2. The first and the second terms are as is, the same. If we replace tangent squared theta plus 1 with secant squared theta, secant squared theta over secant squared theta will cancel out, and we are left with integral of d theta. And the integral of d theta is theta. So this term is equal to 1/2 times theta. And here, to remove the negative exponent, we take u in the denominator. You get 1 over 5u. But we let u earlier as x squared plus 4. So this term simplifies to 1 over 5 times x squared plus 4. And the last term is 1 over 5 secant squared theta d theta over the square of secant squared theta. The square of secant squared theta is secant theta to the power 4, or secant to the power 4 theta. And secant squared theta over, that is secant theta squared over secant theta to the power 4 simplifies to 1 over secant theta squared. So this last term simplifies to 1 over 5 times the integral of d theta over secant squared theta, or 1 over 5 times the integral of d theta over secant theta squared. Again, secant squared theta. In the denominator, we have secant squared theta to the power 2. That's secant to the power 4 theta. And secant squared theta over secant to the power 4 theta simplifies to 1 over secant squared theta multiplied by d theta. And we take that integral. Earlier, we let x equals 2 tangent theta. Earlier, we let x equals to tangent theta and we solve for theta from this equation. Divide both sides by 2. X divided by 2 is x over 2. 2 tangent theta divided by 2 is tangent theta. Therefore, theta is the arctangent or shift tangent of x over 2. Now, secant theta is equal to, by one of the reciprocal relations, which is also a Pythagorean identity, secant is the reciprocal of cosine, or secant theta is 1 over cosine. One of the reciprocal relations, secant theta is 1 over cosine, or the reciprocal of cosine is secant theta. And from this identity, we take the square of both sides. So secant squared theta is equal to square of 1 is 1 over square of cosine, cosine squared theta. We replace secant squared theta with 1 over cosine squared theta. And the last term will simplify to 1 over 5 times the integral of cosine squared theta d theta. Then the first two terms are the same. Now we replace theta with shift tangent of x over 2 multiplied by 1/2. This term is the same, 1 over 5 times x squared plus 4. And the last term, 1 over 5 times the integral of d theta over secant squared theta simplifies to 1 over 5 times the integral of cosine squared theta d theta. Because in the denominator we have secant squared theta, which is equal to 1 over cosine squared theta. And d theta over 1 over cosine squared theta simplifies to cosine squared theta d theta. And to integrate the last term, we make use of another identity for the cosine of twice an angle. As I said earlier, to integrate 1 over 5 times the integral of cosine squared theta d theta, we now make use of a trigonometric identity for cosine of twice an angle. The cosine of twice an angle is equal to twice the square of cosine minus 1. And from this equation, we solve for square of cosine theta. We transpose minus 1 to the left-hand side and we divide both sides by 2. Hence, cosine squared theta is equal to cosine 2 theta plus 1 divided by 2. And in this integral, we replace cosine squared theta with cosine 2 theta plus 1 over 2. And we get 1 over 5 times the integral of cosine 2 theta plus 1 over 2 with respect to theta. The first four terms are the same. The last term is now equal to 1 over 5 multiplied by 1 half. 1 over 2 is a constant. So we can take that out of the integral sign and multiply by 1 over 5. We get 1 over 10 times the integral of cosine 2 theta plus 1. And this by integration rule is equal to the integral of cosine 2 theta with respect to theta plus the integral of d theta. Again, the first four terms are the same. The integral of cosine 2 theta plus 1 with respect to theta by integration rule is equal to the sum of the integral of cosine 2 theta and the integral of d theta. Now, the integral of d theta is theta, and here we have to make use of a substitution by letting w equals 2 theta. If we let w equals 2 theta, differentiating both sides, the left hand side with respect to w, derivative of w with respect to w is 1, multiplied by dw. Derivative of 2 theta with respect to theta is 2, multiplied by d theta. And we have d theta in this integral, so we solve for d theta from this equation by dividing both sides by 2. D theta divided by 2 is d theta equals dw divided by 2. In this integral, we replace 2 theta with w, and d theta we replace with dw over 2. And we integrate with respect to dw. And as I said earlier, the integral of d theta is theta, where theta is equal to shift tangent of x over 2 because we let x equals 2 tangent theta. And the first four terms are the same. If d theta is replaced with dw over 2, we have 1/2 times dw. And 1/2 is, so this integral of cosine 2 theta is equal to 1/2 times the integral of cosine w with respect to w. The integral of cosine 2 theta d theta is equal to 1/2 times the integral of cosine w dw, where 2 theta is replaced with w, and d theta is replaced with dw over 2. That's why we have 1/2 in the coefficient of this integral. And the integral of d theta is theta. And since we are almost done with the integration of all the terms. And after we integrate this term with respect to dw, we will write the constant of integration c. And the integral of cosine w with respect to w is sine w. The given integral is now equal to these first four terms. The first four terms are the same, plus, now we distribute 1 over 10. 1 over 10 times 1/2 is 1 over 20, times the integral of cosine w is sine w. 1 over 10 times theta is 1 over 10 theta. Plus the constant of integration. Since we have integrated every term, we now write a constant of integration. And the first four terms are the same. We replace w with 2 theta. And theta we replace with shift tangent of x over 2. Again, we replace theta with shift tangent of x over 2. So that our answer will be in terms of the original variable x. And shift tangent of x over 2 is obtained from the substitution we made use earlier. U equals 2 tangent, x equals 2 tangent theta. And from that equation, we get theta equals shift tangent of x over 2. We now replace theta here with shift tangent of x over 2. And the first four terms are the same. This is now plus 1 over 20 times sine of 2. From here, theta is replaced with shift tangent of x over 2 multiplied by 2. So this is plus 1 over 20 times sine of 2 times theta, shift tangent of x over 2. And the last term is 1 over 10 times tangent, arctangent of x over 2 plus c. And this is the complete solution of our first example for integration by partial fraction case 4.